All right. Good morning, everyone. Today we're going to start our discussion of an introduction to panel data regression. Okay, we're going to learn why panel data is different from multiple linear regression. So we're going to make use of the data that I shared with you, which is price.csv. So if you take a look at this, if you click this, if we view it, you'll see that let's wait for it. Okay. Notice that you have the variables firm, year. This is current ratio, debt to equity ratio. These are all financial metrics, earnings per share, ROA, total asset turnover, return on equity, net profit margin, interest rate, exchange rate, and price. Okay, so you have a combination of economic and financial data here. Okay, and there are 81 observations, and it seems as if, okay, it doesn't look like a CSV file, okay, because if you notice that there are no commas here, okay, but let's try to run this using, okay, so let's see. If we use, okay, let me pause for a while, and maybe you haven't loaded your packages first. So let's load the packages. In case you get a message that this package is not available, then kindly, just like mine, warning, it's okay. Error in library far away, no package. So we'll have to install that package here. Install far away there, far away, and install. All right, I'll give you a few minutes, class, to make sure that the packages are installed. If they're not yet installed, make sure. For example, this one also, there's no package called FBasics, then I'll have to install this. FBA here, FBasics. There, install. Right, run again. Okay. So when you have installed the packages, please kindly chat so that I know if I may continue the discussion or not. Thank you, Andrea. Yes, Rahul. You need to make a new project, please. Just like here, this is my folder for FinStar, and this is my folder for project for multiple linear regression, and another project for panel data. Thank you for asking.
Sir, just to make sure, once I press new project, is it a Quattro project?
No, RMD. RMD. We're not using an a Quarto here. File, new project. I have to, if I'm going to make a new project, I'll have to close this. So, not a Quarto. Are you referring to a new RMD file?
Yes, sir. So I have to press new project.
Sige, could you kindly share your screen, Rahul? Okay, let me stop sharing, please. Just want to make sure that I got your question. Okay, new directory. Okay, or if you want, you can, yeah, new project, and then new directory. Okay, new project there. You can name it panel data, and you can there. That's okay. And then open a new. You can open a new session to the left. Oops, okay.
Okay na ito, sir.
Okay, yan, nasa panel data ka na. And then, I uploaded two files, okay, CSV files in our Canvas.
Yes, sir. I
Uh,
downloaded.
okay, good. Save it in our panel data project.
Okay, sir.
Okay, thank you. Okay, any other clarifications, questions? Okay, good. Thank you. I hope everybody's done. Okay, as I said, I decided not to share the whole code with you. I'm going to share it partially. Okay. All right. I hope everybody's done with loading the packages. Now, we learned before that you can load a particular data here. Let's load price.csv here. Okay, Control Alt I. Let's create a code chunk, and then we can create this object. Let's say price Alt minus, and then what was the code that we were using, class, for a CSV file? Anyone? What code? What function do we use, class, in order to access a particular code? Hello? Okay. Read underscore CSV. Okay. Yes. Sophia, kindly share your answer to everyone, please. Okay. Can you run that, class? Read underscore CSV. And let's run the price.csv file. Okay. Thank you. Read underscore CSV. And then, since our file is loaded here in the project itself, we can just access price underscore dot CSV. And do I need to put something here, class? What else do I need to put there? Is this okay, class? Hello, class. Is this okay? Should I end there? Uh, no response from the class. Should we put column names is equal to true? Col names is equal to T. Okay, will this run, class? I'll run this. Okay, so it run, right? However, take note, 80 columns and 80 rows and 1 column specification. So if I view this, something's weird about this. If I view this, class, view, price. Okay. So what's wrong with this, class? Not wrong, what happened to our data? Are you getting this, class? Are you getting only one column and 80 rows of observation? Only one column. Okay. So only one column, class, and then you have 80 rows of observation. So what does this tell us? This tells us that apparently your delimiter is not is not a CSV. This is not a comma separated value. Okay. So what do we do, class? What do we do? Because you don't know the delimiter, it could be a tab, it could be a what else? Space. So the best way to do this, class, once you tried read underscore CSV, is to try to uh, load it using import dataset here. Okay, we can do this import dataset, and then you see from text base or from text read R. So let's use read R here, and then it tells us where is your data file or URL. I can link it here to our here to our R project browse, and then here it's here, right? This is in our panel data project. So this is what I need, price, and then open. Now what do you see, class? Okay, you can see that when we loaded it, it's still like this. So maybe we ought to change the delimiter, okay, because it's not a CSV file. If I click this, okay, I can try semicolon. Okay, you notice that now the delimiter, delim is equal to semicolon, but it's still not still the same. Or I can try tab. Okay, now we got it, class. So the delimiter was a tab, and it's you code it by delim is equal to /t. So this is for a technically TSV, tab separated values. Okay, and there are some escape underscore double trim WS white. We can just look at what's the meaning of this one, class. Okay, I leave that to you. But now notice that we have the correct uh, presentation of our data. Okay, name is price. First name row as names. Okay, which means that this is column names is equal to true. Okay, open data viewer. We were shown. Okay, so what's critical here, class? What's new here, which we haven't discussed before, is this one. So if I, for example, used white space, okay, yeah, it will still work here, right? And it's read underscore table. The command is not read underscore CSV, but read underscore table, then price that CSV. Okay, or if you want to use others, you have to specify here the character delimiter. Okay, so either we use this one, the tab, okay, the tab separated value, or we use the white here, white space. And the code for there is read underscore table. And we're getting the correct uh, loading of the data. So let's just use the tab separated values and then import there. And then the view will show us that we have correctly downloaded our data. So be careful with that, class. If you encounter something like this where you only have one column, then no problem. Okay. What you can do is go up here, and for reference purposes, you can copy this, class. You can copy this code in the code chunk in the console, and then copy it here to your here, Control V. And make sure you remove the plus here. Okay, there. Okay, so that's the code, class, for the delimiter, which is a tab. Okay, let me pause for a while, and are you able to get it, class? So it's not only comma separated values, class. Okay, you can have the semicolon separated value or the tab separated values. Are we good so far, class? Kindly please chat. If there are any questions, were you able to get this? Please share your answer to everyone. Okay, thank you, John. How about the others, please? Okay, good. Let's wait for the others to give their feedback. Okay, so this is the first time, class, that we met a tab separated value. So be aware of that, because not all data are formatted as a CSV. Okay, good. Thank you so much for your feedback. Now let's go to the structure. Let's see. Structure, Control Enter. So here we have, okay, the firm, the year. This is your current ratio. So we have here, as I mentioned a while ago, these are financial metrics data, and all of them are considered as okay, as numeric. Okay, if I look at our data again, price. So let's study our data first. Notice that the first one is firm. And how many firms are there, class? How many firms do we have in this data? How many firms? Kindly share your answer to everyone, please. Okay, ano nga pala, everyone. How many firms? 80? No, there are only 16 firms. Okay, take a look at this, class. Let's take a look at our data. Firm 1, this is 2015. So when we get to 2016, firm 1 again. Okay, and then 2017, firm 1 again. So data is obtained from firm 1 from 2015 up to 2019. See there. 2015, 16, 17, 18, 19. 5 years of data and then 16 companies. So you have 16 companies times 5, that's 80. That's where we get the 80 observations. So take note, this is not a cross-sectional data. Okay? You have several years or several periods of observation. 5 years, 2015, 2016, 2017. Okay? And then you have several individuals. 16 individuals, okay, by 5 years of observation. Okay, 16 times 5, that's 80. Then this constitutes a panel data. Okay, okay, as we discussed before, if this was only, let's say 2020 only, okay, 1 year, and then you have 80 companies, 80 companies, 1 year of observation, it becomes a cross-sectional data. Okay, if this was, on the other hand, just one individual, and then 80 years of observation, then that becomes a time series data. Okay, so just to remind everyone, the difference between time series, okay, cross-sectional data, cross-sectional, time series, and you have panel data. Okay, so in terms of unit, in terms of individual, okay, cross-sectional has many, right? Many. But the time series period is only one. Only one. 1 year, 1 week, 1 month. Okay. Did I do here? Sorry. In terms of unit, no? So for time series, you only have 1 unit. And then for panel data, you have many. And then for the period, just to remind everybody, for the period, for the cross-sectional data, you have only 1 period, 1 year. For the time series data, although you have 1 unit, but you have many, many periods, let's say from 1990 up to 2024. And you only have 1 firm where you're only looking at 1 unit. Okay, so that's a time series. The opposite is your cross-sectional. And then, of course, the panel data combines the many units of cross-sectional and the many periods of time series. So this is many and many, which makes panel data more robust than any of this, than cross-sectional or time series. So usually, class, in your papers, in your research papers, it's so seldom to do a cross-sectional data or a time series data. Mostly it will be panel data because you combine the robustness of both the unit, number of units, and also the number of periods. So here we were able to show that indeed this is panel data. And there are two types of panel data. You have balanced and you have unbalanced. So what's balanced panel data? Okay, you have here 16 firms. And these 16 firms appear on all the time periods, 2015. If you go to 2016, 1 to 6, 2016, firm number 1 to 16 is present. Then if you go to 2017, firm 1 to 17 is also present. Until 2019, all the firms are present. So that's what we have here. It's a balanced panel data. Okay. What's an unbalanced panel data? Let's say you have maybe 1 to 5 in 2015, and then in 2016 it could be it could be only 2, 3, 4, and another one 6. So 1 and 2 are not present anymore in 2016. So there are some companies, or in this case firms, that enter and they might exit. Okay, so that's what we call an unbalanced panel data. Okay, in this case, it's balanced because all the companies, all the firms, okay, are present for all the number of periods, which is 5 periods: 2015, 16, 17, 18, 19. All right, let me pause for a while and maybe request your feedback, class, if you were able to get that, the distinction between cross-sectional, time series, and panel data. You get it, class? Or any questions, any clarifications? Okay, thank you. Panel data object. I shared it, it's in Canvas. Nasa Canvas, no? If you open our Canvas here. So you have two data sets here that I shared. Kindly download this and then save it in your R project. James, you get the answer?
Sir, yeah, I loaded them na po, and I'm not sure if because we already loaded the price CSV, right?
Yeah.
Yep. And we turned them into the price object, so uh I might have missed
Yeah.
how we
Would you like to share your screen para I can help you out? I'll stop share. Sige, James, kindly please.
wait lang po, sir.
Sige, it's okay. I don't want you to be left out. All right. So what did you do here? You have price, you have loaded price.
Sir, ito po. When I'm trying to view it.
Sige nga. Just run the view. Panel data. Okay. Kasi, all right, what we should view is the price data kasi what's existing is price.
Oh,
James, di
okay,
ba
sir.
wala ka pang what's row 23? We created the object called price, right? So you
Yes,
have
sir.
to replace that panel data, view price. It should be view price.
Okay.
Okay, because you don't have that object panel data. Okay, run that please. And then also your structure there. Okay, there you go.
Thank you, sir.
Okay, sure. Thank you. Thank you, James. Any questions, class? Any other questions? Please feel free to ask a question. How about James? James 2. James, would
It's
you like to share your screen?
good on my end na rin po, sir.
Ah,
I
good
just
na.
did what
Okay, sige.
James 1 did po.
Sorry, James.
I just did what James 1
Okay,
did.
good. All right. Thank you. Thank you, James 1 and 2. Okay, let's continue, class. Okay. All right. Now, if this was just a cross-sectional multiple linear regression, then what we would have done was to model. We would have ignored firm and year. Okay, we would have treated this as one occurring or happening at one point in time, let's say 2019, 2020, and then all of this will be different companies. Okay, we would have disregarded the fact that there are 5 companies, 16 companies, and that there are 5 periods, which is important for panel data. But if it's cross-sectional data, then we would have ignored the firm and the year, treated this this whole data from CR, current ratio to price, as data of 80 companies, okay, occurring at one point in time. That's your cross-section. That's your cross-sectional data. That's your multiple linear regression. But in this case, we're not going to do that. We're going to preserve the fact that there are 16 companies and 5 periods. So what do we do with this one? Okay. So first, okay. Now I'm using price here. Okay. So sorry, class, malito, no? This should have been, okay.
Sir, sorry po.
There is,
Your screen is not shared.
sorry. Okay. My screen is not shared. Sorry. Okay. Now, apologies to James a while ago because James followed this code. However, this run, because I already have this data, panel data. So what we can do is that in order to, so that I don't have to change the panel data here, let's just create panel data, and then alt minus, and then price. Okay. So we're going to create another data called panel data, and that's the same as your price data set. So let's run this, control enter. Okay, and view. Now, James, you can run now yung view panel data and the structure panel data, because you now have the panel data object here, which is the same as your price data. Okay. All right, let me give you a few seconds to do that, class, so that we're all on the same page. And if I get, once again, the structure of panel data, we'll have this. So this is a special table, 80 by 12, 80 rows of observation by 12 columns. It's a special table, a data frame, and you have firm, which is numeric from 1 to 80, year, numeric also from 1 to 80, and then you have your current ratio until price, okay, and they're all numeric, and some financial metrics, return on equity, TATO, etc. Okay. And then what we do now is we're going to create another object, okay? And we're going to convert our panel data object into a data frame. So we use this function pdata.frame in order to convert our our data into a panel data. And this is very important. We have to index, we have to define, okay? Because remember, class, for your panel data, you have your individual and your year period. So the individual here, if we take a look at our panel data, this one, our individual is the firm. This is the unit, okay? And the period is the year. So we have to define that here. We're creating this P data or panel data, which we use the function P data.frame. What are we converting? The object panel data, and then we define the index is equal to firm and year. Okay, so if I run this, we now have this object P data. It's still 80 observations of 12 variables, but if we view this, okay, so you notice that it's still the same. However, it automatically rearranged it. How was it rearranged? Notice now, okay, for the panel data, let me go back here. The index is your 1 up to 80. For your panel data, this P data, you notice that your index changed. You have here 1, 2015, 1, 2016, 1, 2017. So you now have your index for both your unit, your individual, and then your time. So this is firm 1 from 2015, 2016, 2017, 2018, 2019. And if you go down here, this is firm 16, okay? 2015, 16, 17, 18, 19. Right? What changed was the order of your data, okay? It became per firm, and then you have the years here, firm 2, 2015 to 2019, etc. Okay, so let me pause for a while and allow you to examine your data. Okay, and please give me a chat, class, if you're okay. Okay, done. Thank you, Natanya. How about the others? Okay, good. Okay, good. Okay. Thank you, everyone. All right, so you notice now that the panel data has a different structure. Unlike this one, which is the data frame, this is just an ordinary data frame. You can see the index here is just the ordinal number from 1 up to 80 observations. This one, for our P data, okay, the index is now different. And that all because we run this P data. In fact, let's take a look at the structure of P data. Let's see if it's different. What's different between P data and panel data? Okay. So now here you can see that it's P data.frame, panel data. Okay, it's also in a sense a data frame. And you also notice that the firm and the year were converted into into factors. Okay, so it's no longer numerical. These are factors now. Diba? Yung firm natin, it's a factor with 16 levels. So it will not treat 1 to 16 as numerical. Also, yung year, no? Here, year class. Factor with 5 levels. It will not treat 2015, 2016 as numerical. But the others, okay, Okay, where are the others? Strange. It didn't show, class. No, it's just a repetition. Okay, so it just gave us the structure of the firm and the year. Sorry. Ito pala, no? Firm year, CR class. Okay. CR is numeric, right? Debt equity ratio is also numeric. The rest are numeric, no problem. EPS, numeric, etc. Okay. So it it gave us the structure of all of the whole data. Okay. Okay, so let me okay. Now we can create plots, no, for the let's say here price given the year, given the firm, type is equal to line. So let me share this code with you, Control C. However, if you have a large number of let's say firms, this might not look very good. So we're plotting here the price per year. Okay, price each year by firm. So it will separate now the different prices, the different prices on a annual basis by firm. So let's run first the first one, Control C. Okay. So what do you notice here? Okay, you have 2016, 2015, 2016, 2017. Okay, and 20 up to 2019. So these are your years. You have separate plots here. Okay. 2015, 16, 17, 18, 19, etc. And what do you have here, class? What are these? What are these, class? On the y-axis are the prices. On the x-axis are your years. So this is for 2015, 2016, 2017, 2018, 2019. And it plots, class, although as I said, it's not a good way to represent because it's on a per firm basis. Okay, but it's not really the presentation does not really look good even if we maximize this. There are other ways to plot this. Let's start first with the basic ones. It's taking long. Or you can use the next option, which is by points. Okay. So what do this mean, class? What do this mean? Can you decipher, class, the meaning of this one? And what's this, class? Can you tell me, class? On the y-axis, you have the prices, right? On the x-axis, you have your year, 2015, 16, 17, 18, 19. But what do this mean? This one, class. And then on top, you have given your firm. Anyone? Okay, I'll give you class. I'll let you decipher what that means, class. Madali lang actually, no? May clue na tayo dito. We have a clue here. Firm. You have the price here, and then you have the year here. Or you can, if you want, you can. The only difference here is that this is B, points and lines. Control Enter. Okay. This one. Any idea, class, what this is? Any guess? Okay, may nag-answer yata. Okay. Sophia, kindly share your answer to everyone, please. Sophia. All right. Yeah, in principle, that's correct. No, how prices varies across different firms over the years. The only, for example, ito class tingnan nyo to 2017, ano? Okay, you can see here several shapes. There are actually how many shapes here, or how many observations here for 2017? How many firms do we have? So we have 16 firms. Okay, so how the prices vary for each firm across the years. But we only have three parameters, class. Okay, number one is the year component, this one. Number two is the price component, the one that we want to see. Okay, the price, and also the firm. So this, although the presentation is not so good, I'll give another one in a while, class, a better one. If this were only, let's say, three or four or five firms, then the plot would have been better understood. Okay, but because you have 16 firms here, then this simply means, class, that the choice of the plot may not be this type of plot, the co-plot, okay, because it plots, class, the price given the year, okay, for each year, given the firm. Okay, so if you have data where you have a manageable number of firms, for example, and manageable number of years, then you can clearly see the co-plot to be quite effective. I wanted to show it here so that so that you know that using co-plot to create a graph of the differences of the variable across all the firms across different time periods uh, might not be a good idea if you have several firms or several variables. Okay. What if we use the scatter plot? What will happen here, class? Okay, let me share this with you. Control C, so that we save on time. Okay, so this is the scatter plot, class. This is from the car package. So price associated with year by firm. Okay, and then our data is equal to wait, let me see. Panel data. Okay, here, class. All right. I'm sure for this one, you'll be able to understand it clearly. So what do we have here? You have the year here, you have the prices, and you have different lines. Now, as you can see, class, it's hardly distinguishable because you have different color and shape code for each firm. Okay, however, since the prices are, most of them are very much the same, you cannot really see the distinction between the different prices of the different 16 firms. What's so obvious is number 6 here. Number 6, the price of number 6 really went down across the time period 2015 up to 2019. There were some, this orange one is, okay, so difficult to, it's 11 here. Okay, it's barely increasing across the time frame. Okay, so there's plotting the different units and the different time frame in a panel data is quite tricky, especially if you have if you have a huge, okay, huge data for either the units, individuals, or the time frame. Okay, so let's take a look at this one. Another way to plot it, Control C. Let me share it with you. Okay, so I hope we can go to pooled OLS. Okay, so this one, let's, okay. So what do we find here? Only film number 5 and number 6. Okay, yung box plot nila, no? Malaking difference ng minimum and maximum nila. For the others, it's practically the same, konti lang differences ng across the years. For the other firms, film number 5, number 6, and number 11, their prices have been show differing variance. Okay, so if you take a look at this, plot means price associated with firm. On the other hand, this one, plot means price associated with year. Okay, what's the difference? Here, what you plot is the years. Okay, so you can see here the plot of the differences between the firms. Across the years 2015, 2016, you notice that the in 2015 there was a great difference between the 16 firms in terms of price, but in 2019 the difference was not that big anymore. Okay, so that's what this shows: the heterogeneity, the non-constancy of the variance across the years. This one, on the other hand, is the non-constancy of the price across firms. Okay, across firms, and across the years. All right. So we can create descriptive statistics class. So we use the F basics. We can individually, let me Control C. We can individually get the descriptive statistics of each of the variables. Control V. Okay. For example, so I'm using basic stats for the, let me start with price. Control Enter. So we have here number of observations, how many NAs, minimum value, maximum value, first quartile, third quartile, second quartile, median, mean. For number 2, lower confidence level of the mean, upper confidence level of the mean, with the variance, standard deviation, skewness, and kurtosis. Okay, so as I said before, I will not anymore discuss so much the descriptive statistics. That's your role already to review what those metrics mean, what's skewness, what is kurtosis, etc. So you can do that for all the other variables. Okay, so for example, let me get your net profit margin. Okay, so you have this. Okay, so if for example you're discussing, let's say your dependent variable is, for example, only price, then it's good to get the descriptive statistics of price and also the other relevant independent variables. Okay, any questions so far, class, as far as our panel data is concerned? As far as your panel data is concerned, any questions, class? Okay, good. Thank you. All right. Now we go to the modeling of panel data. There are 3 methods, class. You have your pooled, fixed, and random. So let me share this 3 with you. So we're just looking at the basics first, class. Control C, Control V. At least we're able to get to the 3 models. Okay. At least we can run, class, the 3 methods, and then we'll discuss the differences, okay, which is the better model in our next meetings. Okay. So first, pooled method. What is pooled method, class? If you take a look at our panel data, for pooled method, we're going to disregard this, the firm and the year. So we're going to treat this as if this is just an ordinary least squares. It's just like a cross-sectional data. So we will not bother with the panel data, the firm and the year. So this one will be just like, okay, current ratio, etc. We will be modeling this and we will disregard the firm and the year. Okay, so pooled OLS is just like MLS, multiple linear regression. So how do we run that, class? What we want to model is price. So regressed on this variables, class, current ratio, etc. And your data, our data is equal to P data, and the model is pooling. Okay, model is pooling. So if I run this, class, pooled method, Control Enter, and then let's view this, and you can see that this is a list. Error in what? Okay, ayaw niya. Bakit? Okay. Anyway, so this runs an error term, no? Put a question here. Let's summarize it. Summary. Okay. What do you have, class? What do you have? So notice also that what we're using is not LM. What are we using, class? It's PLM, panel linear model. Okay, even if this is just pooling, even if it's the same as just LM, class. Okay, but just to distinguish it, notice here, PLM, price regress on all your variables. Okay, data is equal to our P data, model is equal to pooling. So we're told that it's a balanced panel data. Number of periods is 16. Number of units is 5. Number of observations is 80. Okay, and take a look at the result class. The result is practically the same as an OLS, a multiple linear regression. Of course, I'm not including here class the interaction. And usually class, it's best to include interaction as we showed last time class, including the quadratic form of the variables. But for this one, we'll just, because I'm just introducing panel data, pooled OLS. So let's see. If I, okay, let's copy this class, Control C, and I'll go here. Control Alt I, Control V. Okay, I'm going to create another method here. Let's create another method, OLS, okay? And I'm going to remove the LM, okay? And then this is our regression. And then the pooling class, I'll remove that and treat this as if this is just a simple OLS. Okay, so if I run this and then create a summary OLS method, run this class. Okay, what do you have? Exactly the same as your panel linear model. This one class 0.004, 3 stars. What was the other one here? 0.004, 3 stars. So the pooling method class in panel data regression is just the same as your OLS. Okay, now let's run this class. I have 2 more minutes. At least we're able to run. We're going to, please spend some time studying. Okay, I'll remove this class, the view here. Sorry, Control Z. I'll just comment this out. I don't know why it's not running. Fixed method class. Okay, same thing, PLM, and then same predictors. Then the model class is within. So that's the difference between pooled OLS and fixed OLS, fixed panel data. Model is within. Here, model is pooling there. So let's run this and see how will this differ. Summary. All right. Now, what do you notice? Notice now that there is no intercept, right? And also, you have R squared at 66% here. For your pooled OLS, your R squared is, your adjusted R squared is only 18%. Okay, 18%. In fact, in your pooling here, your adjusted R squared is, yeah, 18%, same thing. All right, so there's a difference between your pooled here and your fixed here. And in your fixed method, you have here your 3 variables that are highly significant and interest rate at only 10%. So there's a difference between how you perform your pooled OLS and your fixed OLS. And then this one class, random method. Let's run this. Control Enter. Come on, run. It's almost time. All right. Then for your random class, okay, only EPS is significant. Okay. In fact, it's different, no? And the and the adjusted R squared is also 18%. So this shows us that in this case, where model is equal to random, Okay. Okay, the random method was almost just practically the same as the pooled OLS. Okay. And then so you have three methods, class. May I have one last minute? If you need to go, just you may go, class. Okay. Then let me share this tree with you. Here, Control C. After you do the pooled OLS, okay, and then the fixed effects, and then the random effects class, you will have to check which of the three methods are better. Okay. So kindly copy that here, class. You have the Chow's test or the F test. So we're comparing, class, fixed method versus pooled method. What happens here? Okay. The null hypothesis here is that, here, class, null hypothesis, pooled OLS is better as compared to fixed OLS. But the p-value says that it's very, very low, below 0.05. So if you're going to compare fixed effects and pooled OLS, then fixed effect is better. Here, class, here. Okay, let's start with the third one. Okay. Okay. So here for the PLM test, Lagrange multiplier test, we're comparing the pooled and the OLS. Okay, so we run this. Okay. Control Enter. Come on, R. What's happening with you? Okay. Here. The null hypothesis here, class, is that the pooled OLS is better. And the p-value is way, way below 0.05. Therefore, we reject the null hypothesis that the pooled OLS is better. The random effects is better than pooled. And lastly, class, this one, the Houseman test, where we test whether, which is better, the fixed method or the random method. The null hypothesis here is that the random effect model is better. And when we run this, okay, you see here that the p-value is less than 0.05. Therefore, we reject the null hypothesis that random effects model is better. The fixed effect model is better, class. Okay, so let me stop there for now, class. Okay, so for now, we have shown that there are three methods in panel data regression, the most popular ones, the pooled OLS, which is just the same as ordinary least squares, the fixed effect, and the random effects. Okay. So usually, magtatalo lang class yung is there a fixed effect or a random effect? Okay. Next week is independent learning week, but allow me, class, to please post a video this week on the continuation of panel data. Okay, because we're really running out of time and we have lots of things to cover. Okay, is there any question, class? Any question, class, as far as the panel data model is concerned? I hope at least you learned the rudiments of panel data regression. Comment sa case nyo, class, kasi case kasi yan, no? So if it's only something technical, but if you're going to show me your case, it's like me pre-checking your paper, no? So just to be fair to everyone, siguro kung generic concerns lang, no? But for you to show me your paper and then parang sasabihin ko na kung ano yung gagawin nyo dapat, no? All right? So I hope you understand, class, no? So this is I'm not trying to wait, huh? Let me just stop recording.